In this video, I'm going to show you how to take raw data, like you would have with a general social survey, and use a pivot table to cross-tabulate it. We're then going to conduct a chi-square test to see whether the distribution of the dependent variable varies across the categories of the independent variable, and then we're going to make some simple comparisons of a couple cells in the table. So we're in the workbook 1618 crosstab chi-square test, and we are in the worksheet spanking. So what do these variables mean? We have spank and we have sex. Now, some of you may be thinking that these are somehow associated. Maybe you have some kind of, you see these together and you have some kind of idea of what these variables mean. Well, let's look at the code book and see what they say. So spank means how often did your parents spank you as a child? And you can see that responses range from often to never. 1, 2, 3, 4, and -1 is our missing data. And sex is simply your gender or your sex, male versus female, 1, 2. We have missing data, and that's coded as 9. So this is perhaps a different question than you might have been thinking. So I have here the steps how to perform a cross-tabulation, and what I'm telling you here is to click on a single cell in the data. So you can, if you wanted to, you could select all of them, but if there's space separating the data from everything else in the table, you can just click on a single cell, and it's going to guess where the boundaries of the data are. So to create a pivot table, what we want to do is to click on Insert, and then select Pivot Table. And in this box that comes up here, you want to put it in this worksheet, just to make it a little bit easier to work with. And for the location, let's put it right over here. I'm going to click in cell G3, and it's popping up in this box here. I'm going to click OK. Now here is our pivot table. Now it's not yet constructed. What we have to do is place values into the pivot table. So it has our 3 variables here, just some random ID number. We don't really need that for this problem. And we have our 2 other variables, spank and we have sex. Now what I'm telling you in the information over in the left is to put the independent variable into the columns and the dependent variable into rows. So which one is which? Well, usually something like gender, sex, race, these are going to be independent variables. So this is something that's a biological characteristic, and we're going to place it into the column labels. And we want to know whether, based on those biological characteristics, that people are going to vary in terms of whether or not they've been spanked as a child or not. So spank is going to be our dependent variable, which we're going to place into the rows. And you can place any one of these 3 variables into the values box, and in this case I'm just going to arbitrarily place sex down into that box. This is giving you the sum, which is not what you want, so we have to think what we want. We want to count up the number of people who have a value of 1 and 1. So if you remember, it was male and were often spanked. So what we do to change this to a count is to click down here in the values item and click on value field settings. And in this box that comes up, we want to change this to count, which is going to give us what we want. And click OK. So now this is the count, and you can see that there is also some missing data. This row here is missing data, and if you remember from the code book, this was missing data. So we want to go ahead and get rid of them. So just like in the last video, filtering them away, we can remove the -1, which was missing. Click OK. And we can also remove the 9, which was missing data as well. So now we have a pretty compact table, and we have our frequencies. They're all right here, and everything's been cross-tabulated for us. So what we want to do here to make this more intelligible is to actually label these categories. So let's go back to our code book and see what they were, just to remind ourselves. So we know that this was male and female. So I can type that in here. Male with a tab, female. I can adjust this size here like that. And going back down to the code book, what was our dependent variable? Our dependent variable is how often do your parents spank you as a child. We had one is often, sometimes, rarely, and never. So let's see if I can remember that. Often, sometimes, rarely, and never. And it's always a good idea just to double check to make sure we have that correct. So often, sometimes, rarely, never. Often, sometimes, rarely, never. Make sure we don't have any typos here, because this is going to be reproduced, this table, in various different places. So if you do it right once, this is copy and paste, and we copy and paste it correctly. So this is our cross-tabulation right here. So our next goal is to conduct a chi-square test to see whether or not the distribution of our dependent variable, whether or not a child has been spanked, varies upon the sex of that child. Okay, so maybe males or females tend to be treated more physically by their parents because of their gender. Well, our dependent variable was the frequency of having been spanked as a child by the parents, and our independent variable was the respondent's sex. We know that both of these are categories, and for a chi-square test it's important to know that we need categorical variables, so we cannot have numbers. We can't have an interval level variable. And just to review, this is a nominal level variable, and this one is ordinal, because we can see that these frequencies often, sometimes, rarely, never, they can be ranked, and here they are ranked for us. How many rows do we have? Well, often, sometimes, rarely, never. That would be 4. How many columns do we have? Well, we had male and female. That would be 2. And this problem is asking us to conduct a hypothesis test at the alpha equals 0.01 level of significance. I'm going to make sure we have our decimal points there so that we can see that number there. So our hypothesis is going to be that, well, what's our population of interest? So, maybe we see variation in the sample, but we want to know our population among adults in the US, the frequency of having been spanked as a child varies by sex. And I'll just copy that for our null hypothesis. The frequency of having been spanked as a child does not vary by sex. So step 2, we want to calculate our critical chi-square statistic. In order to do that, we need our alpha and our degrees of freedom. So what is our degrees of freedom? It's the number of rows minus 1, rows minus 1, times the number of columns minus 1. And our critical chi-square statistic, we use the formula chi-square inverse right-tailed, and our probability is 0.01, our alpha, and our degrees of freedom was the 3. And hit enter. So here we have our critical chi-square statistic of 11.34. So if we want to think about that in terms of the chart that I've placed over here, this would be the value right here, the critical chi-square statistic. If we have a value that's bigger than that for our sample chi-square, we're going to reject a null hypothesis. A value that's smaller, we're going to go with our null hypothesis. So for the next step, what we want to do, we have to construct our chi-square table. And in order to do that, we need to think about this formula right here. How do we make that? So what I'm suggesting we do here is to copy the entire pivot table, highlight it like this. I click Control C. It's been copied. You can see the copy box is around it. And I'm going to paste it right here. I'll put it in K35. So I'm going to right click and I'm going to say paste as values. There's different options here how you want to paste it. I could just paste a pivot table again. But that's not what I want for a variety of reasons. If you go ahead and do that, that's fine, but it makes things a little more difficult to work with the formulas actually. So that's why we're pasting this as values here, just to get the numbers only. We need to make sure when we construct our chi-square table that we keep track of each and every cell that we have. So each cell. So what do I mean by each cell? So each of these 8 cells we're going to list right here. So we have the males who were spanked often. We have males who were spanked sometimes, male rarely, male never. And then we have the female often, female sometimes, female rarely, female never. So that's a lot of the work is out of the way, just making sure that we've matched up each of these cells. So the number of males that were spanked often, this is going to be our frequency that's actually observed in our sample. Our F0 is for the frequency of observed people, is just going to be the number of males who were spanked often. Enter. And if we've done this right, often, sometimes, rarely, never, this formula we can just copy down for the males. It's going to give us those same numbers because it's a relative reference. And for the females, we have often, and if we copy down that cell there from often, it's going to give us the sometimes, the rarely, and the never. So we can see these values are identical. The next step is to calculate, well, what would we expect to find if the rate of spanking did not vary, whether someone was a male or a female? Well, what we would expect to find is the calculation of this number right here, the expected frequency. And this formula here is our row marginal for this particular cell. Our row marginal is 236 times our column marginal, which is right here. So we have our row marginal of male often, and we have our column marginal of male often. And we're going to divide that by the total. Now, when I copy this down, I want to have this move down to male often, sometimes, rarely, never, but I want to keep these the same, right, just for these 4s. I'm going to highlight these, and I'm going to hit F4 to lock them. I'll hit Enter. So this is our expected frequency, and I can just drag this down for the men. And you can see if I peek inside of the cell by either double-clicking or hitting F2, it's showing me that indeed it has gone to, for male never, we have the row marginal and the column marginal divided by the total. Everything is color-coded. We can do the same thing for female often. So what's the row marginal of female often? It's going to be this one here. And we're going to multiply by the column marginal for female often. So moving over, this time female, what is the total number of females? 644 divided by our grand total of the whole entire sample size. And we're going to lock these using F4. Hit Enter, and I'll drag that down. And again, it's always good practice to see. I'll choose one at random. Female sometimes. You can see this is female sometimes, and I'm using the row marginal times the column marginal divided by the total. And it's actually done that for us automatically. And our next step here is to actually go ahead and calculate F minus FE squared divided by FE. Enter. So we have this calculation for this one. So everything's relative. It's only these two cells. So if I copy this one down, it's going to all be relative, and it's going to give me the numbers that are corresponding here. So all of that's done. And what we wanted to do here was to sum up these values. And to do that, I'm going to hit Alt and equals. Holding in Alt, you hit equals and it automatically sums it. Or we could have just typed in this formula equals sum. I'll hit enter. And this is our, I'll hit Control B to make that bold. This is our sample chi-statistic. This was our critical chi-statistic. So for step 4, which one is bigger? Well, our sample chi-square is bigger than our critical chi-square value. So that means that we're going to reject our null hypothesis, or another way of saying the same thing, we're going to go with our research hypothesis. So reject the null or accept the research hypothesis. So our critical statistic is right here, and our sample statistic is over here in the critical region. It's over at 72, and this was only 11. So if we're going with our research hypothesis, then our conclusion is going to be that among adults in the US, the frequency of having been spanked as a child varies by sex. So since we did find that there was a significant result, we want to calculate lambda, the strength of the relationship. And lambda, the formula is right here, the number of errors without the independent variable minus the number of errors with the independent variable divided by the number of errors without the independent variable. So what does this mean? So the number of errors in predicting the dependent variable without information about the independent variable. This means if I'm just looking over here, so if I just had this data, okay, so the frequency of being spanked in this sample of 1,256 people, and all I know is that 236 are often, 213 are sometimes. If I had a randomly selected person, and I had to guess which category they fell into, well, if I knew the data from the sample, I would guess the mode, right? So the mode was never, and I'd be right 569 out of 1,256 times. So the number of times I'd be wrong would be the sum of these numbers. Or another way of doing that is just saying that it's this one minus this one, which is going to give us this is the remainder. So what I'm saying here is we do n total for that column minus the mode, the largest frequency in the total column, so the frequency of never, which is going to give us 687. And similarly, what we're going to do here, we're going to sum up for each column, okay, of the independent variable. For each column of it, we're going to do the same exact thing. So if you want to use parentheses, you can. It doesn't matter. It might help you to sort things out. So for the males, what's the biggest one here? Okay, 212. So I do the total for males minus 212. That's going to be the number of errors that I would make in choosing the frequency of spanking for a man. And then I'm going to add to that the number of errors that I would make for a female. So I'm going to do the total number of cases for the females minus the biggest one is 357. So I would make this many errors, which is the difference of these. And you can see that we are going to be running into a problem here using a little bit of foresight, because when we subtract these, which are the same number, we're going to get 0. And this is reflecting a particular problem that when the mode does not differ across the categories of the independent variable, lambda is not a good measure of strength. So we can write out our interpretation for lambda, so we can calculate it if you want. You can see that it's going to be 0. So the number of errors without info on the IV minus with info on the IV divided by without info on the IV. It's going to be 0, as I said, so 687 minus 687 is 0, and we can interpret that according to lambda, we would make 0% fewer errors in predicting the frequency of spanking if we know the respondent's sex. So it might seem like it's weak, but this is just because it happens to be the mode is the biggest one. So there are other measures of strength of relationship that we could use, but we're not going to cover them in this course. So we can just say that it's not necessarily weak, but we can just say that it's not a good measure of strength when it's exactly 0. If it was between anything above 0 and 10%, we would say that it was weak. Between 10 and 20, we would say it was a moderate relationship. And if it's greater than 20, we would say it was a strong relationship. But for this particular special case, it's exactly 0, and we're going to say that it's not a good measure of strength. So our third goal was how to compare the numbers in the crosstabulation. And if you recall from the first unit in this course that we've done, we can't compare frequency distributions that have different sample sizes. So here we have 612 men and 644 women. These are different. We can't just directly compare these. We have to use percentages to make them meaningful. Because we just happen to sample more females, we're going to have more in each of these categories. So is the rarely percentage, is this percentage more than this one or not? We have to do a little bit of mathematics to figure that out. So we have to calculate percentages, and the way to do that is to select the entire pivot table and to copy it and paste it somewhere else. And by somewhere else, I mean here. So I'm going to go back up here to the pivot table. I'm going to select it, Control C to copy it, and I'm going to paste it right here, Control V to paste. And what I'm telling you here is that in the values section, so down here is our values section, we want to change this here. So we don't want the count anymore, we actually want the percentage. So if we're outside of the table, that goes away. If we're in the table, it comes back. We want to change this in value field settings. How do we want to show these values? I go to the Show Values as tab. We want to show them as a percentage. And the convention is to show them as the percentage of the column total. So we want to sum them down. So 100% is going to be in the bottom row. And I'll click OK. So you can see it's gone ahead and done that, and we have some more meaningful comparisons that we can make. Our cross here, so 25% of males were spanked often, compared to 11.96% of females. So for our interpretation, we can say that in this sample, remember this is just sample data, we can say that 25.98% of males said that when they were children, they were spanked often, compared to 11.96% of females. And if we want to compare another row, we can say, for example, in this sample, that let's do the never. So 34.64% of males said that when they were children, they were never spanked, compared to 55.43% of females. So you can see from this sample that boys tend to be spanked more often than girls. Some might call this discipline, and some might call this physical abuse.